let's talk about specific heat. This is a very specific topic. Okay, bedtime. Sorry about that one. Let's start with a definition. All right. Specific heat is the quantity of heat. Remember, heat is energy transfer, but it's the quantity of heat needed to raise the temperature of 1 gram of your substance by 1 degree Celsius. Now, this seems very close to our definition of a calorie. Remember, every substance has a different specific heat, and it depends upon the makeup of that substance. Clearly, a crystal that's got very tightly bound molecules is going to have a different specific heat than a liquid with, big fat molecules that move at a particular speed, or even, helium, which is tiny gas moving at very fast speeds. So the specific heat of any substance is whatever the quantity of heat is needed to raise 1 gram 1 Celsius. Now, imagine you're walking on the beach, and as you walk, your feet are going to burn while you're walking on the sand. So when they get too hot, what do? You go jump in the water. You walk along the water, and it cools off. Well, why does this happen? The sun is shining down on, there's the sun. Oh, I can't see that sun. Let's change it to an orange. The sun is shining down on the sand and the water as well. So why is the sand so much hotter than the water? Well, they both get the same amount of energy. All right, let's make that really clear. The energy is coming down, and you've got the same amount of energy. I'm having trouble with my mouse here. Same amount of energy is hitting the beach as is hitting the sand. However, the water has a much larger specific heat. It takes more energy to heat the water than it does the sand. So the sand gets hotter. Because it's hotter, its temperature is higher, and that temperature difference is what is burning your feet. Physics works. Now, here's this formula. Q, you remember Q is always heat, so the heat absorbed is equal to mc delta T, where m is the mass, and remember we always measure mass in grams, and Cp. Now, don't worry too much about that P there. That just means at the same phase. And times the change in temperature. And the change in temperature is T final minus T initial. Let's look at it this way. Q is heat, and we measure it in joules. All right? Now, I say we measure it in joules. We also might measure it in calories, right? And if we do, that's okay. Just measure it in calories. Mass is usually measured in grams. We may measure it in kilograms. That's all right if we do. Just make sure you measure it in kilograms. The specific heat is going to be given to you in joules per kilogram Celsius or calories gram Celsius. So basically, if we give the heat to you in calories, you're going to want to use the specific heat that uses calories. If we give the heat to you in joules, you want to use a specific heat that uses joules. If we give the heat to you in kilograms, won't usually do that, then make sure your specific heat is calibrated to kilograms. Basically, I'm always going to give you the right specific heat, so don't worry too much about that. Now, change in temperature is, remember, T final minus T initial. Change in temperature can be negative. Think about what this means. If the final temperature is less than the initial temperature, then the temperature goes down, the change in temperature is negative, and that tells you that my heat will be negative. When heat is negative, when heat is negative, that means you've lost heat. When heat is positive, it means you've gained. Kind of makes sense. Now, remember, heat's going to flow until it reaches thermal equilibrium. So heat lost has got to equal heat gained. What does this mean? The heat lost, this is going to be the warmer object. Okay? That's going to be the mass of the warmer times the specific heat of the warmer times the change in temperature of the warmer one. While the heat gained is going to be the cooler one. All right, this is the mass of the second one times the specific heat of the second one times the change in heat of the second one. Now the trick comes right here when you do these, and I know when you do these in chemistry, they do a lot of these. We won't do nearly so many. The change in temperature for the hot one is going to be T hot minus T final, while the change in temperature for the cooler one will be T final minus T cooler. There is a more technically correct way to write this with negative sign out front, but we're not going to worry about that one. Now this TF is final. These are the same temperatures right here. All right. So this is the original temperature of the hotter one, and this is the original temperature of the cooler one. Things to remember. Make sure all units are compatible. Okay, make sure you change whatever you have to match those specific heat units, whether it's joules to calories, or calories to joules, kilograms to grams, or vice versa. And delta T is always going to be the larger minus the cooler, all right? So after we slug through a few problems, those will make a little bit more sense.